Thank you. So I work for Northern.tech. Northern.tech makes an over-the-air update solution that is open source core, so the client and the main part of the server is open source. My day-to-day job is to help customers either integrate, mender, help with their OTA problems, do proof of concepts with their things. So customers generally come to me with their situations of difficulties, or they've gone halfway through the process and they haven't had an OTA solution and they need something put in. We work with big vendors, small vendors, any kind of things you want. So this is just what we've learned from over the past year of having Zephyr as one of our clients to our server. So why are over-the-air updates so important? Well, the fact is that for years there have been these devices that have been offline for years, and then a small bug has never been patched. There is a possibility of regulation coming, well, there's regulation coming where vulnerabilities are discovered and need to be patched, and also it gives the possibility of unlocking new features that occur. And also there's a real risk of when you're updating a device like this, it's possible that the device is completely broken and bricked and you can't lead to do it, and this is very bad because that means that devices have to be returned, people have to go on site, which is incredibly expensive, and it erodes trust, and it has destroyed brands in the past. And Zephyr, Northern.tech chose to be their first real-time operating system to have a client because it fitted well with our model, and it is used in things from light bulbs to cars. So we've also discovered that a lot of our clients, they have devices that are in the field that are that end up being stuck or broken, and they can't deal with them, and then getting them over the update, getting them into up to an update position gets quite hard. So we've helped customers that have had systems where they haven't had an online system, and then they've come to us with an actual a device that needs to be updated, and we've helped them with that. So we're a security-first company, and we believe that we should do the updates correctly and with from the start, and not worry too much, and making sure that it's easy. And we've seen so many projects that have been rushed and gone to the field quickly, where they haven't been properly provisioned. They've been put in like beta mode. We've had people fly over with SD cards to their first customers to swap them out, things like that. So this manual flashing process of devices isn't production ready, and it leads to potentially years of headaches for these customers. And they're expensive, like I said before. They erode trust, and we've seen them be really damaging to products. And now in the world where we have to update complex vulnerabilities quickly, it's fast and important to get OTA out. So what do we think the best way of doing it is? We believe that they should be atomic, and you should have fleet management that enables you to see what the update is, and therefore only that update is on that device, and the device hasn't been altered in another way. We believe that they should be fully secured with lots of ways of doing it. One, we have inbuilt mechanisms for both signing our artifacts. We use encryption to get the artifacts down to the device. We have mutual TLS in there, as well as other authentication methods. And also, we believe that fleet management is becoming increasingly important, especially with Zephyr, where they have thousands of devices that might need to be updated, and you don't want them to maybe all updated, or you have different regulatory markers. So fleet management becomes very important. We also discover that a lot of our customers are they have extremely customized situations with different bits being flashed here and there. So these update procedures end up being very, very customized to the customer, which is absolutely fine. It's just that an OTA system has to be flexible enough to support that. And also, it's important to know what your fleet is doing, your fleet of devices, what updates the devices are, and have that properly reported to a system. And also have a system where this is completely auditable and you know what happens. So, when it comes to Zephyr, Zephyr starts off with quite a good system, and we put on the back of that. So we use MCU boot to do A/B flipping to prevent bricking. We can use the off-the-shelf signing mechanisms in in MCU boot and in Zephyr to secure the artifact and the boot process. And also, Mender helps do it at scale because our system has over 1 million devices in it at the moment. And also, we believe that we don't want to have our customers have any vendor lock-in. So we like having a heterogeneous fleet. So our fleet could be many Linux devices, or many Zephyr devices, or other devices there. So what tends to happen is that you end up with different topologies for the update procedures that happens with these devices. And many of our customers have different situations. So a lot of the time that happens is that when you get your first MCU, is that actually it's a sub-device. A lot of systems have gateway devices, and they can have one or many Zephyr or other MCUs. And Mender has a system for updating those Zephyr devices or any other device or anything else or a Docker container under it. So we believe that's a system we see countless times in the market. But also now we're also seeing the situation where actually Zephyr is the primary device as they get more powerful. And also sometimes it goes even further, and Zephyr is the primary device and also sub-devices. So as a subsystem, you have the main Linux system running the update software. It does the management. It can do the flashing. It can actually handle rollback. It can store an extra binary of the file. But also, so you don't need to worry too much about A/B flipping on the actual device. So you don't need to have a rollback mechanism on the MC itself. And then it's very flexible. You could have UART, USB, whatever you want to handle it. But the gateway itself handles the network connection. This is really good. This is kind of the things that we'd see in cars and 3D printers and electrical control systems and like reasonably complicated systems that happen. And this is quite a standard layout. But as we can see, increasingly Zephyr is going to become a more standalone device in our field because Mender traditionally has come from a Linux world where that's happened. So that's our stance on it. So, but we're seeing more and more Zephyr devices, and then the Zephyr client has to handle more things regarding like connectivity, and then the device. The difficulties there is that you have to store the update as it's downloading, validate that it's correct, and then reboot and rollback, and that all has to be handled by the device. And then it also might have difficulties routing to a network. There might be low-speed connection there. But what we're also seeing is the opposite a lot. We're seeing this system whereby they might have hundreds of MCUs and actually managing and orchestrating this massive fleet of devices under one system becomes incredibly complicated. And actually having the visibility of that system to know that all your sub-devices have been updated gets incredibly hard. So we have a new system called Orchestrator that handles this kind of system. And here I'm talking about Zephyr, and I'm talking about MCUs, but it also handles things like Docker containers. But this also helps very much with heterogeneous fleets, because here you can have a fleet which maybe have 2 of these MCUs, or can have many. So when we're looking at tools to do this over the update, obviously I come from Mender. It's my job. I put Mender in stuff. It's not the only one out there. So there were a few. There's MCU Manager, but that doesn't connect to a central server, so you have to add something on extra to get the reporting back. And you could absolutely use that with Mender and have it flashed as like a sub-device and have that flashed that way. Update Hub, that is also good, but it's tightly linked to Foundries and some Yocto. Hawkbit, there are clients, but all the clients, Hawkbit's great, but all the clients, they're just self-made ones that connect to Hawkbit. Mender, a heterogeneous solution where some bits of it, the enterprise solution, are paid for, but the client and the open source bit of the server are open source, so you can run it yourself, and we would never know about it. And in fact, it happened many times when a customer was, well, the customer, a person that uses Mender comes along and says, I've got several thousand devices, and you go, okay, well, we've never heard about you, that's great, but they're running it all locally themselves, and they're quite happy. And then there's Golith, which seems good, but it's all closed source and tricky with other issues like that. So Mender itself, Mender for many years, Mender is about 10 years old now. It has all the features you'd expect from an OTA. It has artifact signing, we host it, you have different update modules, you can update applications, we don't get in the way of secure boot, we have all kinds of weird clients that have like different network situations that are on secure networks, so we have a gateway device, we have TPM implementations, we have options where you can put in remote terminals to Linux devices, you can send configuration devices. So this is our current status with Zephyr. We have most of the features and we can just do not simple, but a decent OTA. But the other features like troubleshooting where you can actually get a shell there planned for the future, and they'll come. And our many bigger Linux devices, we have Delta updates, so you can have a small update that will update from an entire OS that's small. That's planned for Zephyr, but it's not too high on our agenda because Zephyr updates are quite small anyway. So why Mender? It's been chosen by many companies. It's very, very flexible. It has enterprise features that might be required, and they might be but they're optional. You don't have to do it. If you wish to host your own, just like a small server with the open source features, we do that too. But we also have an enterprise offering. We have clients with hundreds of thousands of devices running on our system. We have a massive amount of clients that have different integrations on Linux devices, so adding Zephyr into that is really good because then they can also manage their Zephyr fleet as well. And we don't believe in vendor lock-in at all, so we don't care which devices you use. We don't care whether you use a NVIDIA board or ESP32s or whatever. And we have a flexible state machine system which allows you to add customization to the update flow, adding user confirmations and things like that in. So if you want to try Mender on Zephyr now, it's really simple. You just set up your Zephyr environment. All you need to do for Mender is basically set two things. The artifact name, which is what the version is, like version 1. You set a tenant token, and the tenant token is a secret key that allows it to access your tenant on the server. And that's it. The rest, in this example here, we have an ESP32, which is one of our reference boards, which has Wi-Fi. So you have to set the Wi-Fi credentials so it will work. That's it. And then you build it, and you pull it from our repository using MCU boot, and then you flash it. And then it will connect, and you can see it, and it works. And that's it. Yes, you can go and see that. There's 6 devices at our booth. You can go and see that working if you wish. And then what's really important when you've gone from the device side is when you end up hitting the management side, when you have these hundreds of thousands of devices. So we have management where you can filter devices, add extra elements for your own scanning, add extra inventory items that you might want to know about the devices, and they can be stored and seen by the server, and they're all API accessible, so you can access them yourself from an external system, and many people do that. They have an external dashboard to Mender, and you can use this to monitor rollbacks, and we have AI to analyze the failures that you might have with updates to check that that's working, and obviously we also have audit logs so that we can have compliance, you know who did what when, and we also have RBAC as well, role-based access control. So, now, the practical lessons we've actually learned from doing this with customers, the actual pain points we've actually discovered. So, paying for the infrastructure is often worth it. The infrastructure cost for Mender, for an open source thing, is about $40-ish per month for 150 devices or so. I have spent meetings with SRE teams, like with the cloud engineers, setting up a server that have spent more than that time doing that. So it cannot be worth it. The amount of time I've spent setting up this infrastructure and hosting it, it definitely wasn't worth it. We should have just paid someone else to do it. So yes, and also, if it goes down and breaks, it becomes a real headache because someone's got to go and fix it. They might be off, they might be ill, there might be only one person that understands it. It's an absolute headache. And also, having a well-built CI/CD pipeline to get your updates absolutely means that your fleet will have features quicker because they can be tested. And with Mender, what you can do is you can push artifacts with API, so you could have a test fleet that's automatically updated every night, for instance. And you could have them, in fact, we did this at my old company. We set it up so that the machines that they were testing, they got the fresh update in the morning, QA came in the morning, and then they tested it, reported bugs, and luckily the developers were in the United States, so we were in Sweden, so they filed all their bugs, and then the developers fixed it. It went through the CI pipeline, updated the devices, and then the next morning, the QA developers woke up and then did some more testing, and it iterated quite quickly like that. On a high level, it becomes really, really hard to manage fleets when you end up with thousands of devices. We've heard about people tracking devices with spreadsheets and losing them, and it becomes an absolute nightmare when you get over more 50 devices. So these things should be, these should be things that are planned early and put in place early. We've also noticed that rollback, and by rollback here I mean A/B flipping. A/B flipping is really hard to put into a device later. You end up repartitioning a device. If you haven't installed 2 partitions on your Linux device, or you haven't set up your ESP32 with having 2 slots in there, it will become a real headache to add that in later. So that should be put in there straight away first. Often the pain points we get are when what's happened is they've done all this development work, and then a client comes to us and they go, oh, no, we need OTA and we're going to ship it tomorrow. And you get, right, okay. And so, yes, that's really important to get in there. And also, with compliance coming on, it's really important to have these features. And also, it's also important to realize what you're going to do and how many you've got to there. So in the future, how many devices, so you can manage where your costs are going to go with the fleet, whether if self-hosting is the right option for you, or whether you're going for like an open source solution and you have to manage that and look after you yourself, or going for a proprietary solution. On the low level, again, the rollbacks need to be applied updates. You have to realize that, especially with these ESP32s, some of our customers have found that the connection they have is incredibly slow. And what ends up happening is that the retry needs to happen over and over and over again, which is absolutely fine. There are mechanisms for retrying and retrying and retrying, but that has to be made aware of, and it can be kind of big of an issue. We've also noticed that actually putting all these libraries in that are necessary for OTA can be a big resource drag, and you need to be careful about what protocols you're going to use. For example, the Zephyr devices that we're using at the moment, example devices, just the source code, just the base thing to do the work of the device, 70K. You put in the whole HTTPS stack, that's another 400K. Obviously not enough for a Linux device, but that's quite a bit on top. Well, it's quite a bit of your 4 meg for maybe an ESP device. And the other issue we found with these smaller devices, opposed to Linux devices, it's very easy in a Linux device to have, we'll just have a daemon. But the update procedure needs to be linked into the threading of the device. You can't have the update procedure getting stalled by some other process it got stored itself, and then you can never update the device, because that can lead the device being stuck and never updated again. We've also noticed that as these devices scale up with these thousands of devices, again, not a problem with the Linux devices so much, well, to some extent they are, but when you get over to thousands of devices, the cost of the infrastructure of all the polling becomes bigger, quicker. Whereas before, if you had a big, complex device that did a lot of stuff, you had just one connection for it. But if you're going for a small device, but lots of devices, that can go up quickly. So picking a protocol to do that, like CoAP or MQTT, is important. And again, the device library and the transmission costs of doing that. And so as in when I mean resources here, we mean both. Often these devices are connected with a modem, so therefore there's resources and like cellular costs, but also then the cloud resources about dealing with all those pollings constantly we've discovered. So the takeaways from this presentation are that the robust API needs to be recoverable, you need to know what's going on, and you need to be absolutely sure that that update has happened. Zephyr gives you a really good building block from doing this, and we can show you orchestration too. And you should start doing your OTA early, get it in there, and then you can forget about it. And also, security and fleet management are now really a must-have. And as we're doing it our starting point was Mender in Linux and things like that, that's where we've had a lot of experience, and then we've taken some of those lessons and migrated them to Zephyr. So, that's it from me. If you would like to go and see demos, we have a demo of the orchestrator, and we have a demo of the Zephyr devices, and we have beer as well. So if you want to come and visit us.
Thank you very much. Are there any questions? Please raise your hand. We can answer them now. We have 10 minutes left. Okay, no questions at all.
Yeah.
Thank you very much for having us today. Yeah, have a good evening. Some applause, please. Everything.